Cameron. Cameron. Tell the kids what time it is. Tell the kids what time it is. Say it's time for Math Academy. Let's go. Thank you for supporting CMA Math Academy. If you're watching on YouTube, don't forget to like, comment, and subscribe for more great CMA math content. Alright guys, so let's go over our what, why, and how we'll know if we successfully learned what we need to learn today. So what are we learning today? Today we're going to talk about key vocabulary terms associated with solving equations. We've already learned some of these terms earlier on in the year, but for one, it's good to go back and brush up on them. And then two, there are some new terms we haven't talked about yet, so this will be a good learning for today. Why are you doing this? We are beginning a new unit over solving equations. Eventually, with this unit, we'll get into what's called systems of equations, which is something new we haven't even looked at yet, but it's a lot of fun. So we want to become familiar with the terms and the vocabulary that we'll be using during these two sections. And then how will I know if I've successfully learned what I needed to learn? So when you're given vocabulary terms associated with solving equations, you will be able to create a question and then use your question to write your summary at the end. So if you have not guessed it yet, we're taking Cornell Notes. Remember, we write our question in the left column, answering those questions in our summary at the very end. Okay, so let's go ahead and let's get started. So as I mentioned before, we're going to be taking Cornell Notes. Remember, the left column is your questions, which you'll be coming up with. The right column is where all of our notes and our examples and everything that we're learning will go. So the first thing you're going to do is up at the top of your notes, first you should have your name, but then after that you're going to put where our unit title box is. You're going to have modeling with linear equations, and then you have your unit objectives and goals that you're going to be filling in to that box. I'm going to give you a few seconds here to do that, and then we'll go over what this is saying. So you're writing right now. Go ahead and start. Alright, so hopefully you've had a chance to jot these things down. So again, as we said before, our title for today's unit that we're moving into is called Modeling with Linear Equations. We know this word linear, we know what that means. So real quick, I want you to turn to your table partner, tell them what linear means. Okay, go. So as we've learned before, linear means a straight line on a graph. So these equations that we're talking about, they're going to make straight lines. Now I'm going to ask you to talk to your table partner again. If these equations are going to be linear equations, I want you to think about and discuss what they're going to look like. So what will they not have if they're going to be linear equations? So talk about that. So hopefully you guys came up with the fact that if they're linear, that means they have no exponents. So these equations that we're looking at today and through this unit will not have any exponents because they're going to be linear. So if we graph them, they'd make a straight line on the graph. Let's go through our unit objectives and goals. When we do this, I'll read. When I stop, you're reading the word that you filled in. So you're participating. Everybody's reading the word that they filled in. Okay, so we're on our first objective or our goal. Again, this is just what we want to get out of this unit. Okay, so the first one says we're going to use solving and the property to solve equations. Okay, so we've talked about distributive property. We've done some problem solving. We've combined like terms, so that's nothing new. Let's go to the second one. Our second goal is that we're going to write equations from, okay, we've actually done that before too. We've written some equations from word problems. And let's go to the third one. We're going to determine the of an equation has. Now we haven't talked about this part before. Here comes our new learning when we get to this section, the different amounts of solutions. Okay? Alright, so let's get started with our first word. So our first word is terms. Everybody say terms. Okay, one more time, everybody say terms. Alright, so let's get into what that means. Okay, so I'm going to give you a second to jot this down. Remember, your example and your vocabulary that you're filling in goes on the right side. We will write the question together here in just a second. So you don't have to write the question yet. You can hang on and we'll do the question all at the same time. So I'm going to give you a few seconds here to write this down. Ready? Begin. All right, so hopefully you have had a chance to write down our information for the word term. We're going to go through our our two little bullets here. Again, you guys are reading your words that you filled in. Okay, so let's go to the top one. So it says a term is any or in an equation. Then our second bullet says when solving equations, only terms that are, which also means the can be. Okay, so over here to the side in your example that you should have written down, this equation right here, remember an equation has an equal sign, so this is an equation, not an expression. This is an equation, has 5 terms. 1, 2, 3, 4, and 5. So every part, or every number, every section that has a variable is a term. And then I've color-coded what's alike, or like terms. So 8x is alike with 6x, and alike with positive 4x. Remember, when you're talking about like terms, you want to gather all the information that's in front of it. So the plus sign goes with the 4x, the minus sign goes with the 9, plus sign goes with the 4, and so on. If it doesn't have any, so 6x doesn't have a plus sign in front of it, we know that's going to be positive. Same thing with 8x. So we can only combine terms that are alike. Okay? All right, so the next thing that we're going to do is we're going to write our question for the word term over in the left column. Remember, when we write our question, I don't want to see questions that just say, what's the definition of term? Or what is a term? We're 8th graders, we can think higher than that. I want you to come up with a better question for the word term. You can use your levels of questioning that I've given you on your table, or they're up on the screen if you don't have access to them. So I'm going to give you a few seconds here. You're going to write your question down for the word term. Go. All right, so hopefully you have your question. Real quick, I'm going to give you a few seconds here. You're going to share it with your table partner. If you are table partner 2, you're going to read your question first. Then table partner 1 is going to read theirs. Okay, so starting with 2s, reading your question, go. Okay, so hopefully you have had a chance to read your question to your partner. Remember, the question is really important. You got to have that written down, because that's how you're going to answer your summary and write your summary at the end of our notes. So if you're struggling to come up with a question, please make sure you ask me or your table partner. Work with each other to get this figured out. So let's go on to our next word. So the next word is really a couple things that we're going to talk about, but it's going to go under the title of equation basics. So everybody say equation basics. One more time, say equation basics. So if we look at equations, here's our information. I'm going to give you again some time to write this down, and then we'll go over it. All right, so you have had time to write this down. Let's go ahead and go over the slide. Again, everybody participating when we get to a word that you filled in. So up at the top of my slide, it reads, equations usually contain parts. So there's 3 little parts or sections that we're going to talk about with equations. So the first one, and you guys have these underlined words first. Okay, so you're going to start us off. The first part of an equation is, okay, and a variable is a letter used to represent some amount. Again, we've talked about this part a lot. We've used variables before. That's nothing new. Let's go down to the next word. The second part is, so a constant is a number that's all by itself. And then lastly, the third part is, and a coefficient is a number paired with a variable. So over here in our example, again, a constant is a number that's by itself. So we have positive 5 over here, that's a constant, and negative 8 over here, that's a constant. And when we say by itself, that just means it's not paired with a variable. Our variables, remember, are x in this case, so we have x and x. Now, we usually use x as a variable, but it could be any letter. So it could be y. We've really used x and y the most, but you could see the letter L or T or J. It doesn't really matter. A variable is a letter, and then a coefficient is the number that's paired with that variable. Okay? So again, this was equation basics. Give you a couple seconds here to write your question. One more time, no questions that say, what's equation basics, or define equation basics, because remember, we want to have a question that really helps us study. So we're going to go back and use these questions to help us study for our quizzes and help us study this vocabulary. So you want a good question that covers those 3 parts of the equation. Go ahead and write your question. Okay, so now that you're done with your question, I'm going to give you a chance to read your question to your table partner. If you are table partner 1, you're going to read first, followed by table partner 2. Go ahead and read your question. All right, so let's move on to our next word, which is inverse operations. Everybody say inverse, say operations. Say inverse operations. Now, this again is nothing new. We have talked about inverse operations quite a bit, so hopefully this is very familiar as we're going through some of these words. So now that I've switched it over, I'm going to give you a minute here. I know there's a little bit more to write down, especially with the examples, so I'm going to give you a little bit longer. Go ahead and write down everything on our slide that goes into our notes. All right, so now that you've had a chance to write everything down, let's go through these slides. So again, our word in this slide is inverse operations. One more time, everybody say inverse operations. All right, so you guys actually start us off on the first bullet. So on 3, we're all going to begin that first bullet. Ready? 1, 2, 3. Operations are used to terms in an equation sign. So again, anytime we're trying to move a value or a term across the equal sign, when it's crossing that middle line, that's when we have to use inverse operations, or the opposite. Okay, let's go to the second bullet. The inverse of is, and it says vice versa because it goes either way. So the inverse of addition is subtraction, but we also know the inverse of subtraction is addition. They go back and forth. Okay, let's look at the last one. The inverse of is, and again, that's vice versa. The inverse of multiplication is division, and the inverse of division is multiplication. So if we look over here at our examples, we can see that in this equation, it started out 2x minus 5 equals 11, and we wanted to move that minus 5 over to the other side to get that x a little closer to being by itself. So instead of subtracting 5, we know the inverse of subtraction is addition, and we add 5 to both sides. One more time, you're going to fill in these two blanks. So it says the inverse of is, and again, that's what we saw right here. Subtraction turns to addition. Let's come down here to number 2. Same equation. So after we've done that inverse of subtraction, which was addition, down here we want to get rid of this 2 and move the 2 to the other side. We know that when a number and a variable, which is the coefficient, okay, so this coefficient number 2 and the variable are next to each other, that's multiplication. And we know, everybody, the inverse of is, so we know the inverse of multiplying is dividing by 2, and we divided by 2 on both sides to get our final answer. Okay, so one more time, the word was inverse operation. Everybody say inverse operation. Very good. So moving over to our question, we're coming up with a question. Also, remember, we don't want to reuse questions we've already used. So we want fresh questions. We also want 8th grade questions. So we're looking at those higher level questions, not using just what is the definition of inverse operation. You guys are smart kids. We can do better than that. Give you a second. Come up with your question. All right, so you've had a second here now to write your question. I would like for you to turn to your table partner, and if you're table partner 2, you're going to read yours first, followed by table partner 1. Everybody sharing their question. Ready, go. Okay, so we're moving into our last vocabulary term for today, which is called types of solution. Everybody say types of solutions. One more time, say types of solutions. Okay, this is the new kind of meat of our lesson that we have not covered yet. So up until now, we've only seen really one type of solution. You'll see that here in just one second, but we're getting ready to move into what you might see as different types. Okay, so I'm going to give you a second again, let you copy this down, and then we will go through it. Go ahead and start writing. All right, so let's go ahead and go through this again. When I get to a blank or one that you filled in, you guys are going to say the word. So again, our word was types of solutions. Everybody say types of solutions. All right, first bullet. There are types of, and when we say solutions, we just mean answers, that you may get when you an equation. Now, here are the 3 types that we're going to look at. Again, you guys have the first word, so you're going to help me out. Ready, go. Solution, and when we have that, that's when a number equals a, okay, so that's the type of solution, one solution right here, where a number equals a variable. That's what we've had basically every time so far this year. So if we look over at our example, we see that when we have the equation 2x equals 4 and we solve that, we get a variable equals a number, or a number equals a variable, that's one solution. So when you get an answer that's just like normal, like what we've had, that's called one solution. One more time, everybody say one solution. All right, let's move down to the second type. So you guys are going to start us off with this first word here. Ready, go. Solution, and that's when a number equals a. Okay, so over here, if we have the equation 2x plus 3 equals 4 plus 2x, and we solve this all the way down, we end up with 3 equals 4, which is weird because there's no more variables. So when you have an answer where a number equals a different number, so 3 and 4 aren't the same numbers. So when a number equals a different number, that's called no solution. Everybody say no solution. One more time, say no solution. All right, now this one down here is kind of strange, so I'm going to give you a second. I want you to turn to your table partner and just read this I word right there. Ready, go. Okay, so let's try this now. Everybody as a class again. You guys are helping us start off. Ready, go. Solutions, and that's when a number equals the. All right, so if we look over here in the corner, we have an example of 2x plus 5 equals 2x plus 5, and when we solve that, we end up with 5 equals 5. Okay, well, if it's a number that equals the exact same number, that's called infinitely many solutions. Everybody say infinitely many solutions. Okay, so real quick before we move on to our question, I want to explain what this means. So when we say there's one solution, that means there's only one right answer that makes this equation true. So for this one, it was 2. So if we think about it, we know that 2 times 2 equals 4. There's only one number that we can put there to make it equal 4. So that means there's only one solution. If we think of no solution, what that's saying is no matter what number we put in here for x, doesn't matter, any number we put in there, we could put in 1, we could put in 1,000,000, doesn't matter, no matter what, there's not going to be a solution. So no matter what we try, we're never going to have an answer that says x equals something, because our x's will always cancel each other out because they're the same amount. Okay, let's look down here. Where it says infinitely many, that's the opposite of no solution. That means no matter what number we put in for x, it's always going to be true. So we know that if we put a 2 in here, let's say that. So 2 times 2 is 4, plus 5 is 9, and over here, 2 times 2 is 4, plus 5 is 9, and we'd have the same number on each side. Okay, so no matter what value we put in for x, it's always going to be true. We're going to end up with a number equals the same number. And these are the two, no solution, infinitely many solution. Those are the new ones for us, and we'll practice this a lot, and you'll really get the hang of it. Okay, so one more time, I want you to write your question. Again, a fresh new question, 8th grade level question over types of solutions. Go ahead and go. All right, so now that you've written your question, go ahead and share it with your table partner, starting with table partner number 1, reading first. Go. All right, we have come to the end of our Cornell Notes. So again, the most important part of our notes is the summary. We're summarizing our learning, making sure that what we learned today really sticks when we write it down on paper. So using complete sentences, everybody say complete sentences. You're going to answer each of the questions that you created. So these are your questions to write your summary for today's notes. You should basically have one sentence for each question you have created. So you don't have to ask me or Mr. Shog how long it should be. Just go ahead. You have one sentence for each of your questions. That'll give you a good solid paragraph of a summary. Okay? Go ahead and start, and then at the end of class here, we're going to share it with our table partner.